Hi, my name is Sarah.
My name is Ryan.
And my name is Sabeen. For our final engineering project, we chose to create a Sudoku player. In this video, we will take you through our code and give you a demonstration of our game.
Sudoku is a logic-based puzzle in which players insert the numbers 1 to 9 into a grid consisting of 9 squares subdivided into a further 9 smaller sub-regions in such a way that every number appears once in each row, column, and sub-region.
First, we found a Sudoku solver online, which is our Sudoku file. The function serves to fill in the grid with random numbers from 1 to 9 and is implemented in our other code.
Our second code, the hard code Sudoku, incorporates the solver and allows us to remove values from the grid based on the difficulty level.
We started off by creating the GUI grid. Instead of using the guide, we decided to create it programmatically. Programmatically means we use subsets of code to create the grid instead of using the GUI editor. Here we created the window for the grid, and then went on to create each individual button that will be used in the game, such as the master button, the normal button, and the easy button, the solve button, and the check button. The next sections of our code create functions that help fill the grid. These two create the general display of the grid. The lockboard function locks the randomly generated numbers into the grid so that the player cannot change them. The next function serves as our error checker. Markboard is an addition to the board checker so that when the value entered is incorrect, the background turns red. When it is correct or empty, the background is green. The next sections of code are the callback functions that we previously mentioned. The easy game function corresponds to the easy peasy button and takes away 20 values from the grid. The normal game function corresponds to the normal button and takes away 40 values from the grid. The master game function corresponds to the master button and takes away 60 values from the grid. The last two are the callbacks for check and solve. They simply check to see if the values entered satisfy the criteria of the rules of the game, and if the player decides to give up, solve generates the solved puzzle. Here's Ryan to demonstrate the use of our code.
Now let's run the program. Here's the easy peasy button. This produces a easy Sudoku puzzle to solve. Here's a normal one. Here's the hardest one. And now to check to make sure the actual function works, we will type in a number right here, which we know is right from the puzzle, and we will also put in a number that is wrong, and we will check this. As you can see, this 8 right here is correct, and the rest of the other green spots show that there's no violations happening, but this red box shows that there's a violation right here. Now, in order to solve the puzzle, to show what the correct answer is, we get our results.
Thank you for watching our demonstration for our Sudoku player. This concludes our Engineering 6 final project.